Okay, so here's a problem which we worked on in class yesterday, and for whatever reason I got sideways, and I want to come back and do it again, this time successfully, right? So using the small x approximation. The reason I want to do this is because it's a super valuable concept, and so I expect to do maybe a couple examples. All right, so a chemist is studying the following equilibrium: oxygen gas with ozone, which has a constant of blank. All right, so he fills a reaction vessel with 10 atmospheres of oxygen gas and then goes from there. All right, so what I've done is I've pulled up a whiteboard. I haven't done any pre-work on the whiteboard. Got to plug my marker in here. I'm going to solve this. I'm trying to do it with as little commentary as possible. So where am I here? Over here. Waiting for my whiteboard to show up. Just a minute here. Didn't have my whiteboard plugged in. Okay, there we go. All right. So it is O2 is in equilibrium with O3, and it's to balance it like that. Okay. So the K expression then is going to be K, and it's Kp is the partial pressure of O3 over the partial pressure of O2, where O3 is squared and O2 is cubed, right? And so we start the reaction out. I think it was with 10 atmospheres of O2, but let's go back over and look at it. It is Kp, we'll write that in a minute. He fills a reaction vessel, 10 atmospheres of oxygen gas, which is O2. So can we predict the equilibrium of O3 using only the tools? I'm assuming yes, but let's go ahead and work through it. Okay, so we start out with the partial pressure, initial, change, equilibrium, right? Start with 10 and with 0. And this is in atmospheres. I don't think that matters, but let's just do it just in case. All right, so we can see that we're going to show up 2x is going to show up here, 2x, and 3x is going to disappear, right? So the equilibrium amount of this is going to be 10 minus 3x, and this is going to be 0 plus 2x. All right, so now we go, all right, this is no big deal. We have right? And so this is going to be 2x, and this is going to be 10 minus 3x, right? Is going to equal k. Now it's time to say, oh yes, it was a small k. It was 6 times 10 to the minus 6, right? Let's go back and verify that. 6 times 10 to the minus 6. So it's a small k. Anything less than 10 to the minus 4, sorry, let's go back over here, is small. So since it's small, we're going to use small x approximation. All right, and what that means is if you have something that's not small, like 10, and you have a small that's added to it, this is basically going to be about the same as 10. So let's come back over here and say this is about the same as 2x squared over 10 cubed, right? And we'll check that assumption in the end. And that's what k is. So let's, what I want to do is I want to take this and bring my new layer up bring my new layer up and write this again because I want to disappear the front layer, okay? K is equal to 2x squared over 10 to the third, or that's what we're going to treat it as. It's really approximate, right? Now let's get rid of this and come up here and say if that's true, then k times 10 to the third is equal to 2x squared. Okay, so oops, that was 2x squared. So 10 to the third k is equal to 4x squared. 10 to the third over 4 k is equal to x squared. So x is going to equal the square root of 10 to the third over 4 times k, which we're ready to put our numbers in here now, right? Square root of 10 to the third times 6 times 10 to the minus 6 over 4. I'm going to take my calculator out now. You should do the same thing. Take your calculator out, and so if I get that wrong, you will have you'll immediately see it. Working on my calculator. 10 to the third times 6 times 10 to the minus 6 equals 0.006 divided by 4 equals 0.0015 in the square root of that, right? 0.0387. I'm going to check this one more time. 0.0387. I'm going to check this one more time because it's obviously so important that we get this right. 0.0387. This time I'm going to say, I'm going to take these two numbers, I'm going to rewrite this as 6 times 10 to the negative 3, right? Because I can just do that. 6 times 10 to the negative 3, 6 times 10 to the minus 3 equals, divided by 4 equals square root 0.03879. That's right. Okay. So that's what x is. Now let's go back over to our first layer, and I'm going to write this on the first layer too. X is equal to 0.03879, right? And I'm going to disappear that layer and come back. Oops, I put it in the wrong layer. To 9, right? And so that means that our final x, or our final partial pressure of O3 is going to be 2 times that, times 2 equals 0.07746. 0.07746 atmospheres, right? Now we need to check it. So we're going to keep that number there, and the way we're going to check it, I'm going to add a new layer. Let's bring this up here. The way we're going to check this is we're going to say 0.00. I'm going to disappear this other layer now. The partial pressure 45967, right? And we know that K is equal to the partial pressure of O3 squared over the partial pressure of O2 cubed, okay? So the partial pressure of O2 is going to equal to 10 minus 3x, remember that? Let me go back here. Remember that was 10 minus 3x. It was here. Well, here it was. Oops. Okay. 10 minus 3x, which is equal to 10 minus, just a minute here, store that, times 3 divided by 2 equals 10 minus 0.11619, which is equal to 9.8838. Okay, and so what we need to do is we need to see if this comes out to be about 6, then we're going to go, yeah, our approximation was good. 88, remember that? 6 times 10 to the negative 6, and this was cubed. 0.07746 squared, and hopefully this will come out to be about 0.06, okay, or 6 times 10 to the negative 6. Let's do this. It's that number cubed, right? and it's on the bottom, times, just a minute here, calculator's not working nicely, okay, 0.07745,967 squared, right, divided by, just a minute here, I'm not using my favorite calculator, so I'm going a little bit slow. 967 squared divided by 9.8838 cubed equals, and it is, wow, love it. All right, so this comes out to be 6.214 times 10 to the minus 6, which is about 6 times 10 to the minus 6, right? And so we confirmed that this is indeed correct. So let's go back over to our explanation and just go down and make sure that we get credit for all this. All right, so I'm not going to read all that, of course, but yeah, 0.7746, which is what we had here, 0.7746, that's right. Let's go back over here. That's what x is. Didn't do a percent on there. I didn't look at any of that percent. Let's look at this. .07746. All right. Well, anyway, they saying 0.07746, and they set x up a little differently, right? We put 2x and 3x here, and they set it up a little bit differently. So their x is their answer. That was the question. What is the final partial pressure of ozone? And they said that was what x was, and we said our final partial pressure of ozone was exactly what they said. All right. So there we go.